Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the laboratory preparation of alkynes. And previously, we looked at the nomenclature and isomerism of alkynes. Today, we are going to look at how they are prepared in the lab and also look at some of the physical properties and do some few questions. So, alkynes are usually prepared and specifically ethyne. You notice you'll be discussing only ethyne because the other members are prepared differently. So for the ethyne is prepared from the reaction of water on calcium carbide. So the reaction is usually very highly exothermic, and so a layer of salt should be put in the above setup so that the calcium carbide above the calcium carbide to absorb the excess heat which prevents the breaking of the flask. So that is a function of the sun. The sun absorbs the excess heat, which prevents cracking. We also add copper 2 sulfate, which is used to catalyze the reaction. So you can see from the setup, we have the water in a dropping funnel, and then we have calcium carbide covered with sand. So the reaction occurs, and we said it's very exothermic to produce ethine. So the chemical equation is going to be calcium carbide plus 2 moles of water to produce calcium hydroxide and ethine. So some of the physical properties of alkynes is that usually colorless gases. We have solids and also liquids that are not poisonous. They're usually slightly soluble in water, and their solubility decreases as also the carbon chain and the molecular mass increase, but they're usually very soluble in organic solvents like tetrachloromethane and methylbenzene. So when you look at the size of the molecule, as we have been saying in the previous groups, as the size of the molecule increases, so does the increase in the strength of the intermolecular forces. So it means as the size increases, we need more energy to break these strong forces. And the next thing is that ethine usually has a pleasant smell when it is usually pure. And then the melting point also increases as the carbon chain increases, just like I've explained. We need in more energy to break the stronger van der Waals forces that are formed from the sides of the molecule. The bigger the size, the stronger the van der Waals forces, and the bigger the melting point and boiling point. So you can see from this summary, ethane, propane, and butane are gases at room temperature, and pentane and hexane are liquids. This is because of their molecular masses. So as you can see, the hexane and pentane have very large number of carbon atoms, or the size of the molecule is bigger in comparison to ethane and propane and butane. So there is stronger intermolecular forces, meaning it becomes stronger and changes states. And then look at a few questions in regards to what we have discussed. So the setup was used to prepare a hydrocarbon. So we have water being added to solid X, and also there is SAD, and then gas Y is given off. So name solid X. So we said solid X is going to be calcium carbide, and give a reason why sand is placed at the bottom. So we said sand absorbs the excess heat from the exothermic reaction, which prevents cracking of the flask. It's a balanced equation for the reaction taking place in the flask. So we said it's calcium carbide and solid reacts with water, which is liquid, to produce calcium hydroxide aqueous plus ethine. Ethine is C2H2 and it's a gas. So when we balance the equation, we put a 2 here. So we have two calciums both sides, two carbons both sides, four hydrogens both sides, and two oxygens. So it is balanced. Next, the diagram below shows a setup of apparatus used in preparation of ethane gas. Study it and answer the questions that follow. So we have liquid A and solid X. It's more or less the setup that we had in the previous question, but you can see the questions are more. So identify liquid A. Liquid A is water, and solid X is calcium carbide. What is the role of SAD in the experiment? We said is to absorb excess heat from the experiment or from the reaction, which prevents cracking of the flask. Write a chemical equation for the reaction. So we said it's calcium carbide, which reacts with water, liquid, to form calcium hydroxide plus ethine, which is a gas. So we placed a 2 here to balance the equation. Then identify the method of gas collection and give reasons why ethane is collected by a bag method. So the method is going to be over water, because we said ethane is slightly soluble in water. It is necessary to ensure that the flask is dry before the experiment starts. Give a reason. So the reason why we need to ensure that it's dry, so what is going to happen is that if the flask is not dry, the water in the flask will react with calcium carbide and ethane is going to will be produced. So you see it's being produced even before the reaction has begun. So that is what is going to happen. And finally, identify a catalyst that can be used in the process. We said you can use copper 2 sulfate. Remember, copper 2 sulfate also is commonly used mostly as a catalyst in most of the reactions. So that brings us to the end in regards to preparation of alkynes and also their physical properties. So in the next lesson, we are going to be looking at some chemical properties of alkynes and finish up the topic. So see you in the next lesson.